Welcome everyone. Today we're going to run scalable and resilient Redis with Kubernetes and Azure Kubernetes Service. Redis is a successful open source in-memory data structure store, first released in 2009. It is most commonly used as a database, cache, and message broker. Developers enjoy Redis for its versatility and simplicity. Low cognitive load makes development fast and efficient. Language support for Redis is very mature with clients across every major language one might expect, with multiple community-supported implementations per language, including Go, Java, Python, and Rust, as well as support for advanced functionality such as Redis Cluster and Redis Sentinel, which enable sharding and master replica topologies respectively. Many other open-source projects integrate with Redis. Just two examples in the cloud-native ecosystem that we contribute to in the CNCF are Dapr, Distributed Application Runtime, and Kda, Kubernetes Event-Driven Autoscaling. Dapr supports Redis for both its state store and pub sub-broker components, and Redis is used by default for local development. Kda has scalers for Redis that support Redis lists and Redis streams, including support for Redis Cluster and Redis Sentinel. So why run Redis containerized or on Kubernetes? Redis is fully supported by managed cloud services such as Azure Cache for Redis, which are often the first choice for customers deploying Redis open source and Redis Enterprise in the cloud. However, there are many valid reasons developers choose to deploy their own instances of Redis. Linux is the recommended deployment platform, and Docker is a seamless cross-platform option to run Redis locally for development purposes. Redis is especially popular on container-oriented cloud-native platforms such as Kubernetes, including managed platforms such as Azure Kubernetes Service. Common reasons to deploy Redis using Docker or Kubernetes include portability. Developers may want a truly vendor-agnostic solution. An open-source application, for example, can be packaged into a Helm chart and be a single Helm install away on any Kubernetes cluster anywhere. Local development. Whether using Docker Compose or Kind Kubernetes in Docker, the benefits of a local containerized development environment which closely mirrors production in the cloud can be significant. Scalability. Rather than remain static, it may make sense for Redis to scale with your application, whether as a sidecar cache to specific components of your application or scaled in cluster with the horizontal pod autoscaler. Kubernetes is often a great choice for scalable compute. Monitoring. Kubernetes has a rich observability ecosystem, and the ability to monitor Redis with tools like Prometheus and Grafana is no exception. So what about resilient and highly available Redis? While Kubernetes can make Redis more resilient, and even a self-healing Singleton Kubernetes service can be better than a standalone virtual machine, true high availability is often desirable. For example, if you're using Redis as a cache, your application may be able to survive the temporary unavailability of Redis under modest load. However, under significant load, the loss of a cache may cause the application to fail. In this section, we'll be using an Azure Kubernetes service cluster, which we will deploy using the Azure CLI. Make sure you have the Azure CLI installed before you continue. Create a resource group. Create an AKS cluster. Install kubectl if you do not have it installed already. Configure kubectl to authenticate to your cluster. Add the Bitnami Helm chart repository. Install the Redis cluster Helm chart. You'll be prompted to set a Redis_password environment variable extracted from the Kubernetes secret. Note this is a bash environment variable. Used via Windows subsystem for Linux, macOS, Linux, etc. If you use another shell, adjust the syntax accordingly. Explore with Redis CLI. Now we'll explore with the Redis CLI. Run a pod inside the cluster that will enable us to connect to Redis using the Redis_password environment variable you set earlier. Connect to the cluster using Redis CLI. Note the C switch is required when connecting to a cluster. Next, run 4 set commands from the CLI. You will see output that indicates the client is being redirected to multiple nodes. The same will apply when you get the values. For a deeper dive into the functionality, Redis has a Redis cluster tutorial which you can follow from the Playing with the Cluster section. It includes sections on writing an example app with Redis RB cluster, resharding the cluster, scripting a resharding operation, a more interesting example with consistency test.rb, and testing the failover. When testing a failover, choose a pod to delete. You will see the pods as follows. Then delete a pod. It will be automatically recreated and you'll see its status as container creating. Now we'll explore with Python. The official Redis client for Python, Redis Cli, now supports Redis cluster. Previously, Python users might have had experience with Grozkin Redis Cli cluster, which the official library's support is now based on, with the original repo becoming a laboratory for Redis and cluster moving forward. Open a new terminal and set the Redis password environment variable. Run a Python container interactively. Install the official Redis Cli package using pip. Run Python in interactive mode. Paste the following snippet at the prompt. Now you have a fully authenticated client, RC. Output the nodes. You'll see the nodes listed as follows. Set and get some values. Finally, create a loop that will L push the current time to now every 2 seconds. You will see the length of the list increase. Switch to the terminal where you ran Redis CLI in the My Redis cluster client pod and run rpop now repeatedly. Next we'll explore with Go. Finally, we will deploy the pre-built container application that will log our new items. This provides an example of how to use the Go Redis package. This example uses the universal client. We provided a pre-built container at ghcr.io ASW101 go-redis-sample:\v1. And you can view the full source code of the sample at github.com/ASW101/go-redis-sample. The repo includes a Docker file that uses a distrolist base image and helper scripts that allow you to run the same container to consume events, the default, and produce events, and replicates the Python example above. You can see the code for the produce and consume functions in main.go, alongside a simple set-get example from the original Go Redis Quick Start. In another terminal window, we will set the Redis_password environment variable as before, and also get the internal endpoints for the My Redis cluster service, which we will provide to the Redis ADDR environment variable. Set the Redis password and Redis ADDR variables, and then deploy the GHCR ASW101 Go Redis sample v1 container. The Go Redis universal client lets us connect using a single node client, a cluster client, or a failover client, depending on whether a single endpoint, multiple endpoints, or a master name are provided. However, unlike the Python client, This snippet does not automatically discover the endpoints, and we are using the internal endpoints of the service for testing purposes only. Do not do this in production. To run the above as a producer, replacing the Python snippet above, you can use the do/kubectl-run-produce.sh script in the repo. do/docker-buildx.sh is an example of the Docker build command for the image. If you want to continue to hack on this inside the cluster without any other dependencies, you could run the ASW101/nvigo container inside your cluster. It uses NeoVim, the GoPlease language server, and an official Golang Docker image. Thank you for exploring resilient and scalable Redis on AKS with us. We'd love to hear any questions you have, and feel free to reach out to us anytime. Thank you.